Because the other functions are co-functions, we get a relationship that's going to help us out here. So sine of x is equal to cosine of pi over 2 minus x. Cosine of x is equal to sine of pi over 2 minus x. Right, that's the whole part of the co-function when they existed in the right triangle. If that was theta, opposite, adjacent, and hypotenuse, the co-function, right? So sine theta is opposite over hypotenuse. Cosine theta was adjacent over hypotenuse. Well, it's this angle over here that's defining the cosine. It's the same as sine, and all the angles in a triangle need to add up to 180 or pi. And if one of them is already pi over 2 or 90, then the other one is pi over 2 minus the angle you have. And so this co-relationship works with all of the functions. It's the function and its co-function are pi over 2 off of each other from it. That means if you were to do a derivative of, well, if we look at the arc functions themselves, then we can say that arc cosine of x is pi over 2 minus arc sine of x. And arc cotangent of x is pi over 2 minus arc tangent of x. Right? Because if we're going from the inverse, we're getting what's inside of the function. And so what's inside of cosine, if I do the arc here, I'm going to get that I'm going to have the arc is going to return to me pi over 2 minus x, and x is what I'm going to get from the arc sine of x over here. So these relationships are tied by the pi over 2, and so arc cosecant of x is pi over 2 minus arc secant of x. Well, if I want to find a derivative of arc cosine of x, then it's the same as finding the derivative of this relationship. And so what we end up having happen here is that this becomes a constant, and I get the derivative, the negative derivative of arc sine of x, and arc sine of x was 1 over 1 minus x squared. So we get negative 1 over 1 minus x squared with the same restriction. And this is going to happen for all of our arc functions. So the derivative of arc cotangent is pi over 2 minus arc tangent of x, or negative the derivative of arc tangent or negative 1 over 1 plus x squared, and the derivative of arc cosecant of x is equal to the derivative of pi over 2 minus arc secant of x, which is negative the derivative of arc secant, which is negative 1 over the absolute value of x squared minus 1, again with our limit that the absolute value of x has to be greater than 1. And so we get some negative signs that appear. But I've already been warning you as we looked at our derivatives to pay attention how the cofunctions will lead us to getting negative signs into things. And I think we can see some of the places these negative signs might be coming from. All right, so that is all our trigonometric functions do. I'm going to do a short video to recap what we have to remember and how we think about it, and then I'll do some examples from 3.8 and 3.9.